everybody! This video, we are going to be talking about something called Gaussian elimination. Like I said, Gauss was one of the first ones that kind of used matrices, and he developed, because he didn't used to have a calculator like we were able to use in that fancy last section, but what he did is he did kind of the same way that we were seeing in our calculator to find the solution to these systems. So what this means, again, this is used to solve systems, so we'll solve this system using Gaussian elimination. That's what we're going to be doing. But what we do is we kind of take this system and set it up. So we set it up all in one matrix. So this one we would set up as 4, 3, and our solution is 9, 2, -1, 7. You can keep dotted lines right here if you want to remember that these are going to be kind of our solutions. So our goal here is to have 1 and 1. So what this kind of means is, like, this is where x was, this is where our y's were. So for this one, this just means x equals 5 and y equals 6. So we had the point, or the solution, 5, 6. This one, say we had like x, y, z. This means 1x is 5, y is -2, z is 8. So that's kind of our goal in these, to have diagonal ones, either diagonal, but usually I'll try to make it look like that, and zeros in all of the other spots. So we do this by adding rows, subtracting rows, dividing rows, and multiplying rows, just like any other operation when we are trying to solve. So there's not really a right or wrong way to go about doing this, as long as you are mathematically correct in what you are doing. So what I want to do is I see that I can eliminate this 4 if I multiply 2 by -2. So if I multiply, remember this is our rows. Rows are going this way, and columns are going up and down. So if I take, this one is called row 1, this one is called row 2. If I take row 2 and multiply it by -2 and add it to row 1, that will eliminate this 4 right here. So if we do that, the way I kind of keep track is I'm going to say that row 1 is now -2 times row 2 plus row 1. So when I do that, it's like -2 times row 2, so -2 times 2, -1 times negative, so -2 times -1, and -2 times 7. So 4 minus 4 is now 0. 3 plus 3 is now 6. 9 minus 14 is now -5. Keep the rest of this the same. And I still have 2, -1, and 7. I made a mistake. Sorry. -2 times -1 is 2 plus 3 is 5. You were probably wondering. My bad, my bad, my bad, my bad, my bad. All right, so now this works out. So if we have 5 and 5, well, I want that to be a 1 so that I can figure out what my y value is. So if I divide this entire row by 1, so now row 1 is now my old row 1. Row 1 divided by 5. So if I do that, I would have 0 divided by 5 divided by 5, and row 2 is still the same thing. So cool. Now this means I found y to be -1. So I have 0 x's there. So I need to eliminate this now. Well, if I just add this row to it, 1 and -1 would make 0. So let's do that. Let's make row 2 is now row 1 plus row 2. So if I do that, I have 0, 1, -1. If I add 1, that's 2, so 0 plus 2 is 2. 1 and -1 make 0. -1 and 7 make 6. So now I can divide this row by 2. So I am left with 0, 1, -1, 1, 0, 3. So it's kind of a way of using elimination, but you're using matrices to help you get there faster. So all this means, again, this is kind of your x column, this is your y column. So this would be the point, -1, 3. That would be our solution. So again, we're trying to get ones in our diagonals. It doesn't matter which diagonal, but as long as we have kind of just one y in all of our equations and one x in all of our equations that we have, that tells us what the variables equal. All right, I'm going to do another one with you guys. So in this one, we have 2x minus 2y, so we have 2, -2, 4, and -2, 3, 6. And again, those are our solutions. If you want to keep that dotted line, you're more than welcome to. All right, so cool. Now I notice it doesn't matter which way you go. You could add row 2 up, or you could add row 1 down. Either way. So I'm just going to say that row 1 is now row 1 plus row 2. All right, so in taking row 1 to row 2, sorry, row 2 to row 1, this is now 0, 3, and -2 make 1, 6 and 4 make 10. Well, that's nice. That's nice. All right, and now I need to get rid of this 3 here. So I need to multiply row 1 by -3 such that it would eliminate this. So now I'm going to take this down. So working down, I'm going to take row 2 now to be -3 times row 1, and I'm going to add that to row 2. So in doing this, I have 0 times -3 is still 0, so then the -2 is -2. 1 times -3 is 0. That's still 1. The top row stays the same. And 10 times -3 is -30, plus 6 is -25. Now this is a -2, so I need to divide this entire row by -2. Top row stays the same, 0, 1, 10. Bottom row becomes -1, 0, +1, 0, 12. So I'm dividing by -2. So all that means, again, y is 10, x is 12. So I have the point 12, 10. That would be your solution. Ready. All right, here we go. With this one, we have x, we have y, we have z. So this one, we're going to have more stuff. So notice with this one, you have 0 y's. Here you have 0 x's. Here you have 0 y's as well. So when we set up our matrix, you need to account for that. So you have 2x, 0 y, 1 z, and our equals 6. We have 0x, 2y, 2z, and it equals 0. We have 1x, 0y, 1z equals 4. All right, how are we going to get rid of some stuff? Well, it looks like if I take this one and I subtract it from here, that gets rid of that one. So let's go ahead and do that. So subtracting, that's 1, 0, subtracting, that's 0, subtracting 2. I leave all of the other ones the same. Cool. All right, now I have one variable by itself. Well, now I can do the same thing backwards, and I could subtract it from here, and then I'll be left with a 1 there. Might as well go ahead and divide this row by 2 at the same time. So the top row is going to stay the same, 1, 0, 0, 2. Divide this row by 2, so 0, 1, 1, 0. This one is being subtracted from here, so 1 minus 1 is 0, 0 minus 0 is 0, 1 minus 0 is 1, 4 minus 2 is 2. And then to get this by itself, here, I need to get my, what is that, y by itself. I can just subtract this row. So we have 1, 0, 0, 2, 0, 1, 0, -2, because we had 1 minus 0, 1 minus 1, 0 minus 2 is -2, 0, 0, 1, 2. Okay, all that means x, y, z. So x equals 2, y is -2, z is 2. So 2, -2, 2. Okay day. All right, looking at one more of these. So again, it says solve using Gaussian. So we have to notice that we have a 0x here and we have a 0y in this one. So I have 1, 1, 1, -1, 0, 1, 1, 2, 2, 0, 2, 2. All right, this whole row can be divided by 2, so you could go ahead and do that if you wanted to. You can also check out this, 1 and 1, 1 and 1. So if we subtract this row into it, So if I subtract my first row by my second, I would have 1 minus 0, 1 minus 1 is 0, 1 minus 1 is 0, negative 1 minus 2 is negative 3. That's one variable by itself. I'll leave this row the same for now. And I'm going to divide this whole row by 2. All right. So now I can get rid of this one right here by subtracting the first line. So I'm going to leave all the rest the same. 1, 0, 0, negative 3, 0, 1, 1, 2. And then now, this minus that is 0. 0 minus 0 is 0. 1 minus 0 is 1. 1 minus a negative 3 is positive 4. Now I can get rid of this one by subtracting that. So I have 1, 0, 0, negative 3. All right, 0 minus 0 is 0. 1 minus 0 is 1. 1 minus 1 is 0. 2 minus 4 is negative 2. 0, 0, 1, 4. Hockey day. X, Y, Z. One's in my diagonals, so that means x is negative 3. So negative 3, negative 2, and z would be 4. That's our solution. All right. I know this is kind of weird stuff right now. It's really strange at first, but you just got to keep practicing, keep asking me questions. Please, 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 please ask a million questions. Whatever you got for me, let me know. I'm here for you guys, and I can't wait to see you. Bye-bye.